the ethics, science, all of it, whether research is done in advance and so on. Now, I've been involved in this myself a bit and been rather stunned at the variety of opinion that exists on this question of governance. I think everyone agrees that it's important, but they don't agree how we should think about it or how we should resolve the problem. In particular, taking, again, extreme positions, some think that there should be no restraints, that actually the thing you don't want is to have some United Nations agreement where unanimity is required and irresponsible countries have a kind of a veto, that actually what you want is you want the restraints off of a country like the United States and let the United States. But the important thing about this technology is that lots of countries could do it. Lots of countries can do it. It's not that only one country can do it. Lots can do it. And that now creates a situation where even the countries that are able to do it may wish to have some arrangement that involves some kind of mutual restraint, because each wants the others not to use it, but each wants the freedom to be able to use it themselves. Now, the other view is that you need to have, and actually I'm in favor myself of a global agreement on this, because all countries would be affected by whatever's done. That's not to say every country should have the veto. That's completely different. But what a global agreement does is it acknowledges that every country will be affected, and it basically creates a space in which countries can, in a sense, negotiate and bargain and work collectively to figure out what is the best thing to do. But there are other people who think that there should be the equivalent of a veto. So I'm sort of curious about the exact, what do you see as being the best kind of governance arrangement for this really quite unprecedented technology? Either one can go first.
I'll go. I think Clive talks a bunch about the analogies to the nuclear weapons world, and I think they're sensible and thoughtful analogies. I think his comments about the way people think in Livermore are ones that are exactly in accord with my experience. I've been struck a lot by reading some of the accounts of what people thought in the very first years of the bomb's creation. And it's interesting that some of those people thought far ahead about the fundamental fact, which I believe to be a fact, that weapons of that power are not really compatible with nation states as we understand nation states. In the 19th century, we, if you like, and before that, kind of had a system where we had nation states that had these kind of arbitrary powers to do their own thing, and when they didn't agree, the ultimate thing they could do is settle by war. Then those wars would cost a few percent of the population. I'm not trivializing that, it was awful, but that was something that this political system could, if you like, tolerate. And with nuclear weapons, you can't do that. You can't settle disputes between states with war. And what that ultimately means is nation states can't be, if we're going to live on this planet, we cannot have nation states of the kind we did before. We require some kind of global governance, which you could argue we are slowly and painfully evolving towards over the time since the invention of those weapons. And I actually think that in the long run, this technology has similar power implications. In the end, there is only one thermostat for the planet. And if we are going to manage this technology stably, including deciding not to use it or deciding when to use it, in a way that doesn't have kind of instabilities that could lead to war between states in the long run, I think that requires some kind of global governance with force. Global governance that can comply states who might arbitrarily want to use it, not to use it. So it requires a kind of reshaping of the global governance system, as do, in fact, many other technologies, genetic technologies. There are essentially a series of far-reaching, profound technologies that humanity is now inventing that make the old system of governance untenable. Exactly how we do that, I don't know. That's a very far-reaching, down 100-year answer. My near-term answer is that we need to pretty quickly start to have multilateral agreements, first kind of agreements in principle that aren't treaties, just memoranda, but that say very clear things about how early experiments are regulated, and then moving up to something that is a treaty.
Well, I think this question of governance is really going to be, in the next few years, a really huge one that most nations are going to have to grapple with, and a few are already starting to think about it now. And with the IPCC report surprising all of us, except those who are perhaps lead authors involved, in including in the summary for policymakers a reference to geoengineering as a potential policy response to climate change. I say we're surprised that it was mentioned in Working Group 1 report. We're expecting it to be mentioned in the reports coming out in April. But as soon as the IPCC starts talking about and therefore normalising geoengineering as a response to climate change, it will become quite soon, I think, a serious political issue. There are a number of proposals around, and the international legal scholars have been making a mini industry out of talking about regulation of geoengineering and what is possible. At the moment, it's a complete mess in terms of international law. One proposal is to change the terms of NMOD, the international treaty that outlaws weather modification for hostile purposes, which arose out of the use by the United States of weather modification techniques during the Vietnam War. And that proposal is to change the definition of hostile to include solar geoengineering. My preferred option would be to develop a new protocol to the Framework Convention on Climate Change. That would have a series of articles covering transparency, oversight, a common evaluation amongst nations of geoengineering technologies, a kind of IPCC for geoengineering technologies, and which would at the same time begin to establish the infrastructure that would be needed to reach any democratic decision over any deployment that might happen in the future. However, I think realpolitik is a more likely outcome. At one scenario that I think is not out of the question is, say, 2030, 2035, there's a severe drought in northern China. There's tremendous social unrest, people are going hungry. The legitimacy of the Communist Party government in Beijing is severely stressed and under question. They can see no way out other than to attempt to take control of the climate, change precipitation patterns, and try to hold on to power that way. And the US president may be approached to see if the US would collaborate. I suspect domestic opposition in the United States would prevent any US president going along with it, but there could well be a nod and a wink that, we'll make public statements opposed, but in fact we're quite glad that you're doing it.
Well, there we go. Fiction or nonfiction?
I pretty much agree with all of what Clive just said.
Well, there we go there. I mean, there actually is, initially we started off with a lot of disagreement, but at least I'm struck that there is some agreement too. Let me ask, and make sure I look at all parts of the audience. We have a microphone to the front, and we're being covered by C-SPAN. So people who would like to ask a question, Peter, if you want to go first, could you identify yourself and then ask your question from the microphone? Yeah, that'd be great.
So it seems to me that solar geoengineering is kind of made for TV, so it's very appropriate that we're being covered. I first met David at a meeting on distributed carbon capture, and then I later saw him at a much more prestigious meeting in Washington, D.C. that focused largely on solar geoengineering. And it struck me that the tenor at those two meetings was very different, and that at the second one there was a lot of staring into the abyss and philosophical discussion. The first one was dominated by kind of practical issues of implementation. So I'd like to ask, both of you have written a book about geoengineering. I'd like to start by asking David, why did you write about that instead of distributed carbon capture?
That's easy. I run a small company. I'm gradually phasing out of running it, but I'm still involved in it. That is trying to develop ways to do carbon capture from the air to make low carbon fuels, to supply the CO2 for algal biofuels, to make transportation fuels that have a low carbon footprint. And as a consequence of running the company, I've done my best to manage the sort of more sharp conflicts of interest by not doing academic work on that topic and not speaking about it except sort of as company president. So I now speak about it in front of green tech audiences and other audience. Basically, I only kind of accept speaking engagements on it if I'm speaking as president of Carbon Engineering, and then I'm pretty disciplined not to use my Harvard hat, not to talk about public policy, just to talk about how I think what our company is doing is useful.
I forgot to introduce myself, which reminds me that we all have conflicts of interest here. So I'm Peter Kellerman, and I'm at Columbia University, and one thing I work on is distributed carbon capture. So, well, that's interesting, David, and I think it's great that you're trying to avoid conflicts of interest, but I think it's easy for the public to both identify and also, in some case, overlook the conflicts of interest that arise in academia. So, to a certain extent, I'm not sure those are that easily separable. We're all making careers out of having views and doing research on various topics, and we all essentially advocate for the topics that we think are interesting.
I think there's sort of sharp versus soft ones. There's a standard in academia now where people have graduate students that are partly funded by their companies in this way that I think is very intertwined, that I am uncomfortable with. But the other difficulty, some of the stuff you've seen arising here, that these two things, because I haven't been doing them, are intertwined in a way that's really messy. So there's a spectrum of kinds of carbon capture from the kind that we're doing, and I would say, and I think even Clive roughly agrees, it may or may not work, but it doesn't present really hard governance challenges of the kind that, say, putting iron in the ocean does, or even biochar does, because it's very easy to quantify. Our thing will work or not work, but quantifying the inputs and outputs is pretty easy, and it's the kind of thing that regulators are used to regulating. But because it's hard to explain all that in a short thing, you get this business that Clive and I have been back and forth, where Clive will say that he's talking about solar geoengineering and then talk about all the oil industry money and the patents and so on, most of which are in fact not for solar geoengineering. And because of that confusion, I generally don't do both.
Okay, I have, okay, questions are adding up. Francis, did you want to ask, would you come up and ask at the microphone and introduce yourself?
Should we get to that?
Yeah, that might be good. But hold on, actually I'm taking names, so I'm going to...
Hi, I'm Francis Denning. I'm a postdoc at the Woodrow Wilson School working on climate policy. And I have a technical question, actually, because I guess mostly this is maybe partly lay audience as well. As far as the impact being global, truly global, and not containable in any sort of geographical area, you also said that the effects, as they're understood now, will possibly benefit most people and most ecosystems. Now, implicitly, that obviously won't positively impact everybody, and some regions may be negatively impacted. Now, this ties in with the governance issue that, well, there's obviously a power dynamic as it is, and no matter whether or not this is a global UN FCCC kind of framework, ultimately the ones who can and will be able to do this are going to be countries like the US and China. Now, the regions and ecosystems that are negatively affected are simply those which will not have the power to say no when it comes to it. Then that raises a relatively large distributive issue on the effects of geoengineering, right? And so I'm just wondering, technically, do we know reasonably well what the distributional effects are, and how would that impact how you feel the governance issue should be handled?
Those are hard questions. No, I don't think we know very well now. First of all, there's no one geoengineering. So different schemes of geoengineering have very different answers. And even for the ones that are best studied, we don't have very much. So just for example, for sulfate aerosols, or in fact it's even a simplistic caricature of sulfate aerosols, we published one of the first papers that actually quantitatively looked region by region and showed that in a model, which may not be reality, the effects are much more even than people had thought. And that work has now been replicated by a paper with Alan Roebuck, because obviously he's a critic, getting almost precisely like the same two-digit number that we got using 15 models to show that it's relatively equal. But does that mean it's necessarily equal? No. I don't trust those models that much, and that's an idealized version of climate engineering, so I think we don't know very well. But I want to pick up one other thing you said. You're sort of assuming that, I think probably many of us, certainly Clive and I, share a concern that the world is too much dominated by too unequal, and decisions are too much made by the wealthy in ways that are not equitable. And the question is, how do new technologies like this change that? And I think some technologies tend to exacerbate inequalities, and others the other way around. It's not obvious to me which way this goes. Because it's so cheap, it is in fact not true that only a few powerful nations could do it. So Hindustani Aerospace has the, didn't make that up, I've checked, has the kind of technical capabilities to develop the aircraft and do this easily. So does Embraer, many countries distributed around the world. Arguably, I wouldn't push this too far, this is one of these kind of leveling technologies in the same way as nuclear weapons are. It's not necessarily a good thing. I think that to come back, the bottom line is we can only make these decisions in the end stably. You can think of unstable situations where one state does it, but I think we can only stably make these things with some kind of strong, binding global agreement.
I mean, I think it's a profoundly important question. Not convinced by David's argument that it's a levelizing technology. I mean, I don't see the world standing by and letting North Korea take control of the world's weather. But I'll just make this a point. I think it's an extremely important point you make. But we have to distinguish between differences in impacts that would result from solar geoengineering and differences in perceptions of impacts. And it's really the perceptions of impacts. And I mean, it's going to be partly in America are saying, but there's a very interesting development. There's a lot of investment in geoengineering research in Germany, which acts as a kind of counter to what's happening in the United States, but also local perceptions of how weather has changed. And if there's someone out there playing with the weather, or people even think that there are people out there playing with it, like this crazy chemtrails conspiracy, you can see that you've not only got a lot of very upset people, but perhaps some recourse to international law if people believe that their nation is being damaged by activities by US, China, or some powerful nation in affecting the world's weather.
Okay, Jeff Heel, and then I'm going to be over here after that.
Jeff Heel, Columbia Business School. I just wanted to hear a little bit about the risks associated with the type of geoengineering you were talking about. You both alluded to risks. I mean, putting these sulfate aerosols in the air, does that run the risk of global acid rain? Does it run the risk of PM5, PM2.5, the tropospheric level? What are the possible downsides of this? I'd really appreciate a little bit more clarity on that.
Sure. So I'll give a whack at that. So first of all, I divide these things into two categories. One are a series of things that are risks due to the particular way that we would reflect some sunlight, whatever method we use. And that's sort of inherently method dependent. There isn't a general answer. And then the second thing are either risks, whether you want to call them risks, or lack of efficacy due to the fact that shielding sunlight, even if you did it in a perfect way by magically turning down the sun, doesn't compensate for all of the risks of CO2 in the atmosphere by any means. And so dividing those two up,